Hello everyone, and thank you for coming. My name is Marek Puchalski, and yes, indeed, I am going to speak about security today. Security, in my own experience, is a fascinating topic, but there are some side effects of what you experience by doing security a lot, like suddenly the world around us seems a bit broken, and well, suddenly we realize how we could use, or better to say, misuse the technology to cheat on others. Or maybe even worse, how others could use or misuse the technology to cheat on us. Well, this is a bit of an experience I like to share with you today. Some words about myself. I work for Capgemini office in Wrocław. I don't know if it matters, how far it matters for us in Wrocław, and it obviously matters a lot. We have our own microclimate there. I'm a developer and architect, and I am still coding. Despite the whole security-related stuff you will hear today, I am still coding, I am still designing systems, and I'm fighting every year harder and harder just to keep the connection to the code. So I do not speak irrelevant stuff by talking about security. I'm a security consultant as well with, let's say, about 5 years of experience. I do security testing, a bit of security coding as well. Oh, and if it matters, I'm also an OWASP member. OWASP, anyone knows what OWASP is? Please raise your hand up if you know what OWASP is. Great, about half of this hall. This is actually great. This is the best number I have ever seen. And please raise your hand again if you know any other project of OWASP beside the OWASP top 10. Beside OWASP top 10, anything else? Anything else? Okay, I would say only a handful. Okay, that's a bit surprising, but let's remember this. Let's remember this, it will be relevant for this talk as well. So, I would like to start with a short story first. It will be a short story about a famous tennis coach, and this tennis coach had a habit of asking, before accepting a new pupil, of asking this pupil 2 short questions. The first question was, how important do you think the mental strength, the strength of the mind is when playing tennis? Expressed as that in percents. And the pupils usually answered something about 50%. In their own opinion, it was quite a lot. In the opinion of a coach, well, he thought that the mental strength was even more important, about 70%. Nevertheless, he asked then the next question, which was, how much time do you actually spend training your mental strength? Those 2 questions are questions we can also ask regarding security. How important is security for us, and how much time do we actually spend doing security? So, how important is security for us, for developers, for architects? 50%? I don't think so. I don't think so. I mean, there are probably systems that require us to put 50% of our time in security and 50% in the rest, but there are not probably many of the system, and it is quite unlikely for me or for you to end in development of such systems. So how much is it then? 15, 20, 25, 30%? Is security this important to us? I think it's more likely. I think it's more likely. How much time do we actually spend doing security? I don't know how much you spend on doing security. I know a bit about how much I spend, but to make this whole thing make more sense, I came actually up with a metric, and this metric answers not this question, but a similar question. How much do developers and architects care about security? And this metric is actually quite simple. Let's take a conference. Let's take JDD 2015, for example. Why 2015? Well, because it's less obvious for us. Then let's look on the count of all security-related talks there. And let's divide it through the all talks count. How much do we get if we express the number in percents? How do you think? 5. Anyone more than 5? 2. Okay. 2 is actually correct. Pretty close to 0. Well, there were about 3 or 4 streams a year ago, so it's actually 2. And it is a bit disturbing when you think about it, because 2 is actually pretty close to not caring at all. So in fact, all the people that were a year ago, most of them have not heard anything about security at all. And it is a bit disturbing when you think about it, and it is not about JDD. It's not about JDD. Take any other conference, apply this metric, and you most likely will get a number between 0 and 8, which is quite low. So I would argue that because we care too little, the world looks as it looks. The world is a bit broken, a bit. Okay, and when I say broken, I do not mean that things do not function properly. Well, we would see it in the same moment a thing happens that something does not work. Being broken in terms of security means actually that the solutions does not provide the security you expect it to. So let's use this definition of being broken during this talk. And the statement, the world is broken, is actually quite a strong one, but the problem with this statement is actually not to find facts that support it. It's actually to find facts and to chain them together to give you a better picture and a bit better of understanding of what's going on in the world. Let's start with the first example. Let's start with internet. There's a data transfer going on. There's a data transfer going on between 2 companies, one located in Mexico, one located in Washington, D.C. We have experienced those kinds of troubles with the Beamer during previous talks. I hope it will stabilize. Okay, there's a data transfer going on between Mexico and Washington, D.C., and you see the packages traveling along the green line, and this is actually what you would expect out of it. You would expect the data to travel along the green line, but in this case, Minsk wanted to play a man-in-the-middle attack, and they have misused the border gateway protocol to route all the data over to Europe and then back to Washington, D.C. Surprising, isn't it? You don't get to hear in news about it, but honestly, if you are an internet service provider or a nation, you can do such things. You can play a man-in-the-middle attack inside of a whole internet. Crazy. And the nice thing about it is it is deniable to a certain degree. Meaning, if you're caught red-handed doing something like this, which is hard to do, it's not visible for normal users so easy, then you can say, oh, sorry, one of our servers went berserk, or human error. So this kind of problems happens. There are hundreds of cases like this one, and well, you cannot do anything about it. Another example, this time it's a case that can happen in a local network, and there is a wireless network you are probably in with your devices right now. And this time, this whole kind of attack can be done in a similar way, like the attacker can misuse the ARP protocol, address resolution protocol. It's a protocol that translates the IP addresses on the MAC addresses, on the physical addresses of your network devices, and say, victim, if you want to contact the router, then send the packets to my physical address. And You can also send such a packet to the router and say, hey, router, if you want to send data to the victim, then his physical address is my address. So the thing we have seen in the internet happens also for us locally. And look around you. I mean, you are all, some of you are actually in this wireless network. And the problem with lack of security is about, well, you need to trust everyone here, which is a bit disturbing as well, because we have a problem of trusting one another. And this is so broken on a protocol level that your firewall will not help you to prevent such an attack. There is a mode, there is this gratuitous ARP mode, which depends only on sending the ARP replies. So there is actually a specified mode that bases the whole functionality only on the ARP replies. So you cannot easily block the replies, or you would lose a part of the functionality that they were supposed to provide. But you can actually say, well, wait, we have TLS. Isn't TLS supposed to solve this kind of problems? And this is a fair point. Well, actually it is. I have noticed that not everyone knows what TLS is about. So on a big picture level, TLS is about three things. One thing, server authentication; the other, confidentiality; the other, the third one, integrity. Server authentication meaning you know who you are talking to. Confidentiality means even if someone taps on the wires, even if someone is able to read all the bits and bytes you send, he's not able to understand the message. Well, he will be able to extract some metadata out of this whole data transfer, because when you connect to a Pornhub, even over the means of TLS, then what the attacker will know, he will know that you have sent this package to this kind of server. Well, he will not see the pictures, but he will gain a lot of power over you just by analyzing the metadata. Well, whatever, we can do even better if we use the Tor network, but this is another topic. The third thing is in data integrity. So even if someone taps on the wires and he is able to listen to the data transfer and he is able to modify the data transfer, he cannot modify the data transfer undetected. So actually the principles, the TLS is quite powerful, and actually we should use it. And the latest state of the art when we speak about security is that we use TLS actually everywhere. Everywhere, meaning also our backend connection. And we have noticed some of our customers actually migrating the databases. So every database server connection, even if they stand in the same room, is encrypted. So insane. But if you look about it and if you think about it, if you think about what Nick Wavers said, that every unencrypted traffic is an open attack vector, then the case becomes quite serious one. Actually, TLS also has its flaws. And to understand what problems do we have with TLS, let's ask ourselves a question. Which CA, which certificate authority should you buy certificates from? Any ideas? Let's Encrypt. Anybody votes for Let's Encrypt? One hand up. Two hands. Okay, Let's Encrypt is quite nice because they have really cheap certificates. You do not have to pay anything. So you can have TLS for free. Well, later you will need to pay for the installation and management, but let's say $0 for a certificate is actually quite nice. Okay, the actual answer to this question, which CA should you buy certificates from, is it does not matter. It does not matter which CA you buy certificates from. It's like with getting a loan from the bank. You go to the bank, You take the money, and it does not matter from which bank you got the loan. It's always the same kind of money. You can do the same kind of thing with it. So it's actually quite nice, but there is a little difference between getting loans from the bank and how TLS works. And to know this, let's ask another question. What happens if a CA fails? If a root CA certificate leaks for some kind of reason? And the answer is, everyone is in danger. Everyone is at risk. If one CA fails, and there are many of CAs out there, then every person in the internet is at risk. Let this sink in for a while. I mean, we have created a system that should protect us all. And once again, we must depend on everyone in the system, because if one fails, the whole internet can be compromised. Because if you get access to one CA root certificate, you can fabricate certificates for any domain in the internet. And you can play man-in-the-middle attacks undetected. Nice, isn't it? So how often did CA fails in the past? Well, they did. There was one case in 2011, Komodo got hacked by the Komodo hacker. The same Komodo hacker hacked DigiNotar. DigiNotar went bankrupt the same year. If you think such things do not happen in Europe, then think again. The French government agency was caught red-handed by fabricating a certificate. The latest case I know about, and I have tracked it until 2015, was the case of MCS Holdings. So actually, it's not as safe as you might think with the CAs and with the trust. And thank God they are not selling the certificates to anyone. Well, bad news. Actually, they are. And we have had a case in 2013 of TrustWave, a company who sold an intermediate CA certificate to an unnamed private company. Why? Well, the politically correct answer was because they wanted to support the DLP solution, data leakage protection solution. They wanted to know if their private company's data is not leaving the intranet. So it's actually a nice thing to have such a certificate, because you can unzip the whole TLS, check in all the packages whether they are confidential private company's data, and then encrypt it again and move it to internet. So this company wanted to play kind of a man-in-the-middle attack on its workers. Well, if you express the same thing not in a political correct way, then the company was spying on their own coworkers, which is a bit of sad thing, and it's a nice thing to remember that there is a bit of a conflict of interest between a worker and a company. Okay, if you decide that you're not going to go for TLS, but do your own encryption and design your own crypto systems, then think again, because this is actually quite a hard thing to do. Crypto has proven to be one of the most hardest things to implement. And we have thousands of years of experience of doing crypto the wrong way. And if you want to have an example, as we stand here, we are probably most developers, we have touched code, we have written code ourselves. So you all would probably know how to write a function that compares one array with another array. We would. It's actually quite an easy task to do. So imagine if we use this function we have written in cryptography, then we will have trouble. Why? Because the function that compares one array with the other will leak a lot of information about one array or the other. So this is a kind of depth you must go when you're trying to design your own crypto system. And the other problem with designing your own crypto is crypto is actually a battlefield. So it's a battlefield between nations, between agencies, and they are playing a game where they are trying to make standards out of some protocols for data encryption so that they can decrypt it, but no one else can. And we have seen lots of problems arising because agencies mix their own interest in this whole standard approving process. The latest we have seen was a drone attack. What you can see is actually a data transfer going between a victim and a server, and it's completely fine. It's a TLS 1.2 protected data transfer, but someone misconfigured the server here, and this server also supports SSL version 2, and because it supports it, and there are millions of servers who actually does support such a thing, the connection can be broken with some effort. So that's what the drone attack was about. But what about our applications? What about the stuff we do? Well, unfortunately, what we do is a major problem for the whole IT infrastructure. When you look at the report from the Verizon from the 2015, you can see that the red area, the web application attacks, are actually quite huge, and those are confirmed data breaches. So someone has lost money or reputation or both. And I do not know what your projects are and what you're doing in your projects, but I will make a wild guess. I will make a wild guess and point you to one thing you haven't thought about. And I am quite positive you will find that it is actually something you have not addressed. And the reason I think so is because I have not found not a single team who addressed this problem on their own. And the point is, from the OWASP top 10 list, there is a point number 9, using components with known vulnerabilities. So sometimes you might have actually libraries which becomes vulnerable over time because someone have found vulnerabilities there. So the question is whether you apply some kind of scanner or you have some update process for those vulnerabilities, because they will be fixed, but no one will notice that they need to be replaced. Do you have such a solution? Hands up. 1, 2, 3, 4, and let's count it as 5. More than I thought. Thank you. And I could. Well, thank you. And we could go on with this point, but actually the time will be up. Okay, are we guilty? I will not say that just because we are developers, we are guilty of the whole situation out there, but actually there are people who make exactly this claim. Just because developers are the only people that touch the code, and they are guilty of how the world looks like. I don't know if you have ever been to a security conference. I would suggest to go at least once. It's actually an interesting experience. The last time I was on such a conference, I have learned to open handcuffs without keys and to pick up locks. So there are lots of interesting stuff you can learn there. And those people make exactly the claim. Just because you are a developer, just because you touch the code, you are responsible personally for how the world looks like. So it's actually quite a strong claim. It's actually quite a strong claim whether we are personally responsible for our system and how it all looks. So are we? I don't know. Honestly, my answer is that yes, we are. Yes, we are in terms of touching the code. We write the whole vulnerabilities into the protocols, into the applications. And no, because from what I have learned about religion, the problem of guilt goes quite deep, and we should tackle it a bit. The question to you would be, what's the difference between secure and insecure? You have probably seen some projects that were quite good and some which were lacking the security. And the question for you would be, what was the difference? Was there a difference between one and another? If you had to point on one thing that make the difference, what would it be? Audits. Security testing. Okay, any other guesses? Audits and security testing have a potential actually to spot problems in the software when it's actually too late. I would argue that the main point that can do the difference between secure and insecure are actually security requirements. Why? Because we are developers, we are simple-minded people. We do what is required. We do not do stuff which is not required. So if you change the requirements, we will adapt and we will deliver better security for our systems. Is it this simple? Yes, it is this simple, and no, it isn't. I have a long list of failures of trying to push some security requirements into the projects because of reasons. And there are stories to it. And if you want, I can tell you about it. And right now, if I would write a list, I think I would include 3 points more of what I have heard of projects around Wrocław, let's say. So what helps then? I would like to give you some hints. What should you look after to make your projects more secure? And I will point you to 3 things. One thing you will probably hate, one thing you might be slightly interested in, and the third thing, one thing you will love. You would love if you ever come to this point to actually do this. So, the first thing is your customer system owner. Because the problem that you are not being delivered, the security requirements is actually not a development problem. It actually lies on the side of your customer to a large degree, and what you learn out of information security is that, well, sometimes your customer will not do the things he should do. What should he do? Well, he should specify the business goals for the company. Then, after the business goals for the company are specified, he should run some risk analysis, because it's insane to assume that he will achieve all his goals. So we have a process for this. We have a process called risk analysis, and during the risk analysis, you try to think about what could go wrong. And sometimes, during this risk analysis, you identify some systems as being business relevant or even business critical. And this is a point where you need to look deeper, because if such a system fails, then the business will have problems. In case your customers have trouble with doing it, you can actually help them. And you can help them by using a tool. It's actually quite simple tool. It's the CIA triad, and it is one of many definitions of security out there. So you can go to the customer and ask regarding confidentiality. Ask a question, what if all the data in your system goes public? Is it a problem for you or not? Regarding availability, what if we turn your system off and it will not work for 1 hour, 2 hours, 1 day, 3 days, 5 days? How long will it take to generate a permanent, irreversible damage to your business? Or the question regarding integrity. What if you lose all your data? Or what if some part of the data is corrupted and you do not know which? This is a good point to think about the backup process. So it helps actually to identify what is going to go wrong in the business. And It helps to identify the systems that need special security assurance. How our projects look like, and what do they use for the requirement specification? Well, what I have shown you now is how to identify the systems and how to identify how deep you need to go with the security assurance. It did not tell anything about requirements and how to derive requirements out of it. So let's take a quick look how it is done these days. You've seen the green thing, meaning projects who do their own risk management and security specification. There are those who are not aware of security right now. And there is a yellowish field. This is a picture I have drawn myself. If you want to have white paper information out of it, I have seen similar things in the Sun's white paper, so I can deliver it to you. But what you read out of it is, most of the projects are OWASP Top 10 projects. So people do some kind of security risk analysis, and then they say, dear developer, please comply to OWASP Top 10. And I would argue there are some problems with this approach, and I would say there are two problems. The first one is OWASP Top 10, okay, it is a great tool, but for educational purposes. It's not meant to do any kind of security assurance. And if you ever seen some kind of requirements derived from OWASP Top 10, please ask your customers what it is about. But there are other problems as well, like misunderstanding about what OWASP Top 10 is. And sometimes you might be faced with a problem like your manager comes to you and says, here is a OWASP Top 10 list, it's a short list of 10 things. I think it should take you 1 day to verify your whole project, whether it complies with it or not. Well, it is a trap. Honestly, OWASP Top 10 is about 10 things, but when you think in terms of security verification, it's more like 30 things, and some of them are not easily verifiable. So please look at it, read through it, not only through the table of contents of a document, but through the rest, and you will find that is quite troublesome. So what should we use instead? Actually, you should use another tool from OWASP to derive security requirements, and this tool is called Application Security Verification Standard, and it is the only standard that OWASP ever created. I will only show you this. It's actually the essence of this standard, and this standard is made out of plenty of tables such as this. Every line of this table is one requirement, and you can see there are some numbers, and there are 1, 2, 3 levels, those colors you see. So actually, if you decide to go only through the level 1, which is the basic kind of security assurance, you do all the stuff that is marked as level 1 relevant. If you want to go through level 2, then you do both level 1 and level 2, and there is also a level 3. So if you ever run into problems of a need to specify some security requirements, think about this standard. It actually can help you, and it actually can save you money. And it's not like an ISO standard. There is no auditor that will run and ask you for compliance. It's something that you can take and use for yourself. You can cut off some points, delete it from the list because they will be irrelevant. You can do stuff that matters. So it's about it's OWASP. It's about security. It's not about compliance. So you know what the difference between security and compliance is. The security is the fear of threats, and compliance is the fear of auditors. That's actually the difference. And this is it. We still have 5 minutes time, so I will show you 2 more things that you could do. I would argue that what you have seen right now is the thing that you would hate, because I hate it myself, because it's more about politics than about coding. There are more interesting stuff out there that is more connected with coding, and I will show it to you. This is what we call our standard architecture, and probably you will have a similar one in one of your companies. Standard architecture is a kind of architecture we like to use if our customers do not have any other ideas. So what you can see right here is a lot of Java on the back end and a lot of JavaScript on the front end, a lot of Spring on the back end, very little JEE on the back end, and actually no application servers. That's why I love it. And if you have a kind of a standard architecture that repeats itself, you can take this standard architecture, you can take the security requirements and derive standard solutions out of it. What do I mean by standard solutions? You can actually do stuff like this, like how to enforce authentication on the resource. This is one of the requirements you will face because everyone requires such a thing. And you can put some piece of code that is a simple instant solution. You can actually copy and paste to your project, and then you can update it. And you can show plenty of nice and interesting security stuff with this. Like what you see here is actually definition of exceptions, definition of pages which will not require authentication, and the rest requires authentication. It's a nice way of showing what security, what default security is about. So you can take the ASVS, there are about 80 points that require such verification. You can think in terms of your architecture, and you can come up with solutions like this one. Okay, and the last thing I would like you to show is a bit of security testing. Actually, in our company, it was the first thing we have started with. And the point why we have done it was something what OWASP said about developers who will not deliver secure system if they do not know how to attack them. So we wanted actually to teach our developers how to attack the systems. And there are plenty of tools you might use or need using when you test the security of the systems, and but there will be one you will need more than any other, and it will be a forward proxy. And there is one nice forward proxy from OWASP called OWASP ZAP, and forward proxy actually means it's a proxy you put on your computer right behind your browser. It will record all the traffic, all the requests you make, and all the responses you receive, and it will store them, so later you can look through them. It also has a lot of nice modules like the spider who will go through the website you want to analyze on its own and click in every possible place and run every formula right there. Or there is an active scan, a scanner that will run some basic attack vectors over your system. So look out for this one. Do not run it on a system you're not the owner from. But this is actually quite fun, and you might quite enjoy this one. And what you will realize after you have done this whole thing is that you have built up some people, developers, probably also testers, who will know a great deal about security. And this was actually the nicest experience of the whole thing. We have, it took us about maybe 3 years to reach this point, because right now we have people you cannot find easily on the market who know how to code and how to test for security. And we have a small team that is able to address the security relevant things in our projects. And we are actually quite proud of because of this. Okay. What I have shown you was security requirements, how to deal with it, secure architecture, secure testing. Can you do anything more? Yes, you can. Another tool from OWASP called OpenSUM, Software Assurance Maturity Model. It shows actually what we have talked about today, security requirements, security architecture, security testing. If you want to dig deeper into the whole process, look out for other practices that are defined in this document. We have addressed only those things that are repeatable and that are highly to be reused, but the problem of security goes even deeper than this. Okay, I think the time is up. Any questions?
Ewentualne pytania proszę zadać po prelekcji. Niestety musimy kończyć, ponieważ mamy kolejnego prelegenta.
Sorry, thank you.
Dziękujemy.